Before I go any further, I first want to say thank you for all making the time to be here today. I really do appreciate it, and I'm really happy to share what we think we know about how Westside Fire operated in the past. So maybe some ideas of how it may operate in the future. And then I thought I'd end the talk by just sharing some ideas several of us have come up with over the last year for maybe things we can consider depending on our management objective of what we might want to do before, during, or after a fire. Now, I was a little bummed, but not necessarily surprised that when we all went around to highlight our burning question, no one went for the low-hanging fruit and mentioned fire. You did? I missed it, but thank you. I didn't go for it either, which I think just shows a level of maturity on my part. But there's probably a good reason why fire doesn't float to the top of everyone's mind, and that's because when you look at a map of 32 years of fire footprints, that you can see that, by and large, the vast majority of fires and the vast majority of area burned, it's actually in the eastern half of the state. Right? If you kind of squint your eyes and draw a line along the Cascade Crest, you could almost imagine that there's some imaginary firewall between eastern and western Washington. Almost. But we know in reality that's not true, right? These areas on our Westside forests here in western Washington and northwest Oregon do burn. It's just that for a lot of western Washington, and namely all of those areas on that characteristic fire map behind me painted black, they tend to burn infrequently. But when they burn, they tend to burn with a high severity. So what does that mean? Infrequent means that the time between the big fires that tend to shape the landscape can span centuries rather than, say, decades like in our drier east side forests. High severity conveys the idea that when you get these fires, you tend to get large patches of stand replacing fire where anywhere from 75 to 100% of the trees can burn in these patches. And these large patches could be thousands of acres, tens of thousands of acres, hundreds of thousand acres, and maybe even millions of acres in size. Now, of course, in this infrequent and high severity regime, if you were to look at any fire footprint, you'd actually see a mosaic of severities. And for those of you who can't see the bottom of this slide, what we're looking at is a snapshot of a fire in a high severity type of system. And you can see, again, the defining or most dominant type of patch is this black area, which corresponds to our infrequent and high severity type of fire. But of course, again, not every fire, or very few, would ever be a full moonscape, and you're always going to have patches of, say, mixed severity fire or low severity fire. Now, some of you may notice that that type of fire I just described doesn't really characterize all of western Washington. We could see some areas colored blue or beige in that characteristic map behind me. And they've been defined as moderately frequent or frequent type of fires, meaning that the time between fires could be 50 to 200 years, so much more frequent than our infrequent type. And mixed severity that I'm just going to lump together in those two colors means that these fires tend to result in maybe 25 to 75% of overstory mortality in trees. So a very different pattern, which is reflected down here. You can see there's still some black patches of stand replacing fire, but they're really smaller and within a broader mosaic where moderate severity or very low severity, where just like the understory burns becomes more prevalent. So if we were going to kind of look at the delineation of our different types of fire here in western Washington, they actually seem to correspond pretty well with the topography and climate that we experience here in western Washington. So if you think about the boundary or delineation of those areas that were painted black, they tend to follow, the coast here, the West Cascades, and those are areas where our summer temperatures tend to be a little cooler, our summer precipitation relatively a little higher, and our summer drought stress is a little less. And in contrast, the northeast portion of the peninsula, the lower Puget lowlands or trough, which essentially follows the I-5 corridor, those are areas where Summer precipitation is less, summer temperatures are higher, summer drought stress is a little greater, and that's where we tend to find our mixed severity type of fires. So again, this is a lot of this is driven by the climate and topography of the area. So that's kind of the very basic setting for fire, but I wanted to focus a little bit more on this infrequent and high severity type of fire that really does dominate a lot of Western Washington. So folks have been studying these forests for decades and decades, and we have a really pretty good understanding, we think, of how these forests grow and develop. And then they tend to burn with a significant stand-replacing component every 200 to 600 years. And we have beautiful hand-drawn illustrations to make this point. But we can also visit landscapes out there today and see legacies or fingerprints of past fires, but you just need to know where to look and what to look for. You know, the where to look is kind of obvious. You have to go to those landscapes or forests that haven't been managed or haven't been disturbed for a very long time. Now, for a lot of you, the what you look for is also probably might be a little obvious, because you look for differences in the texture or the color of the forest to kind of help describe or identify different ages of our forests. And I'll show you what I mean by zooming into that middle photograph behind me. So when I look at this picture, what I see are two distinct ages of forest. I see these darker textured or darker green, rougher textured trees here in the foreground and background by those arrows that actually represent true old growth forests. And surrounding those patches of old growth is an ocean of lighter green and smoother textured trees. And they're lighter green and smoother textured because they're trees that are of a younger age and of all of a similar age. And they're all younger and of a similar age because they all originated from a stand-replacing fire about 120 years ago. And just due to vagaries in the topography or weather at the time of the fire, these islands of old growth persisted. So one of the questions that we haven't been able to answer or address very well until recently, in my very biased opinion, is how big could these fire episodes be in this infrequent and stand-replacing system? I mean, if you think about it, it is kind of a hard question to answer because by definition, these fires are rare, so we don't have a lot of examples of them on the landscape. By definition, they're stand-replacing, which means more recent fires tend to burn up evidence of past fires. And then, of course, all of us have greatly modified the landscape and further erasing any sort of signatures of these past fires. So really, the only way to answer this question is through everyone's favorite sort of exercise, a computer simulation or modeling exercise. And you can thank me later. I'm not going to bore you with any of the details of that, although you're welcome to read it in a paper if you need some good sleeping material. But I'll tell you, we ran some computer simulations across 7 million acres in what I'll call the West Cascades. And we ran what I think of as 9 different fire scenarios where we kind of varied assumptions on how the time between fires, whether fires tend to be more clustered or dispersed through space and time. And we took all those different assumptions from the ecological literature, so it was nothing we made up. We just kind of wove these different threads together. And wouldn't you know it, across these 9 fire scenarios, it doesn't matter what assumption you made. The inescapable conclusion that we found was that the largest fire episodes in this landscape probably burned hundreds of thousands, if not millions of acres. And I know I'm just some guy from DNR, you don't know me and trust me, and you think I'm comfortable saying this. It actually took a little while to get there, but probably one of the saving graces for us is we're actually not the first ones to articulate this idea. We know there was a fire episode around 1700 that burned north of 1 million acres on the Olympic Peninsula, and between 3 and 10 million acres in Western Washington. Some of you may be familiar with the Yakult complex back in 1902 that burned north of 1 million acres, we think, across the region. Or maybe you've heard of the Tillamook burn in northwest Oregon in 1933 that burned 350,000 acres. Again, all consistent independent lines of evidence within the framework of those 9 scenarios we ran. More recently, some very smart scientists took this characteristic fire map that we looked at earlier, and on top of that, overlaid historical records of past fires. Some of you may be familiar with the early 1900 land surveys where folks walked the ground and regular intervals recorded in notebooks the kinds of trees in terms of their stature, their species. Now, they also noted the absence or presence of fire. It could have been old fire, it could have been more recent fire, we don't know. But in our infrequent and high severity characteristic fire type, the largest patch recorded was also over 1 million acres, and they recorded 5 patches over 250,000 acres in size. So again, all really sort of consistent evidence. Now, as we started to look at these historical fires and some written accounts of these fires, we noticed that certain ingredients tended to float up over and over again and coincided when we got these big fires, and I thought I'd just take a moment to share them with you. The first thing we noticed is that a lot of these fires tend to happen late in the summer. And by late in the summer, I mean mid-August through end of September, maybe even early October. That kind of makes sense. It's after our forests have had a season of drying out, right? And of course, our forests can be bone dry, but they'll never burn without an ignition source. It's kind of the silly one, but it's still a key ingredient. Now, at least for me, when I think of ignition sources, my mind immediately gravitates to lightning. But when you look at the fire statistics for the last 40 years in Western Washington, on average, 95% of all fire starts have been caused by all of us, right? People. And that doesn't mean we don't get a lot of lightning. It just means we tend to get lightning during the times of year when the plants are wet so they don't ignite a fire. So that's really enough to get any fire in this landscape. And that would include what I think of as more ecologically small to moderate-sized fires that may be tens of thousands of acres. Again, not small by social, economic, or a whole host of other values, but ecologically, within the context of this fire type, kind of small. But in order to get these really large fires that really shape the landscape, what you need is this third key ingredient called synoptic east wind events. Now, typically, our winds blow from the Pacific Ocean across western Washington and into eastern Washington. But during these synoptic east wind events, those patterns reverse. So imagine it's dry, late in the summer. You get a synoptic east wind blowing really hot and dry air from eastern Washington or eastern Oregon or even interior British Columbia over the West Cascades, over the peninsula towards the Pacific. Well, that's when you could get a really large fire in a really short amount of time. I kind of find this daily fire spread map of that Tillamook fire pretty interesting. It started around August 14th, so kind of meets that condition of a dry late summer. It was ignited by people working in the woods. And you can see, though, that for the first 10 days, the fire didn't really spread around that much. It kind of was fairly contained in this area. But on August 24th or 5th, we got our synoptic east wind. And that's when this fire burned 200,000 acres in a day. And it was during those synoptic east winds when the Yakult complex traveled 30 miles in a day and a half. Now, we may not be very familiar with the term synoptic east winds up here, but when we think about a lot of the fires we've read about over the last few years in California and the trouble we've had containing them, we often hear the words Santa Ana winds or Diablo winds associated with those events. Well, it turns out those are also synoptic east winds. It's just they occur so frequently in California that they have a more poetic name for those wind events than we have up here in Washington. So someone's got to work on a name for that, okay? And so my friends and I, or colleagues and I, we've started to think about these fires less as just fire events and almost more as wind events that just so happen to be carrying fire within them, right? Because wind is such a critical factor. And I'm going to say that at some point in the future, we will experience one of these fires again, right? We would experience it even absent a changing climate, Because what I like to remind folks is a lot of the old growth that we have on the landscape today, well, it originated from a stand-replacing fire in the past, right? These are forests that are naturally adapted to stand-replacing fire. It's just part of the way the system operates. And sure, these forests may not be very resistant to fire, meaning that when a fire occurs, those trees may burn up, but at least up today, until today, given enough time, those forests would grow and develop back into the old growth that we have on the landscape. So to me, that's a really important message or idea when we start to think about these events in the future. So that's kind of what we think, or maybe what I think we know about Westside fire in our infrequent and high severity types. And I'm just going to briefly touch on this mixed severity type, right, which is probably in a lot of the geographies that all of you manage, live, and work in. And again, just as a reminder, the patchiness of the fire is going to be very different typically in these mixed severity forests than they are in this high severity forest. And in a lot of cases, not always, you're not going to have the wind-driven fires because, again, fires are more frequent. It's drier, right? Less precipitation. And that means these fires tend to be more driven by what we think of as bottom-up processes like fuels and topography. Right? During those wind-driven events, fuel and topography just don't matter because wind is pushing those flames and those embers across our dry forests. And that also means that without the wind, smaller to more moderate types of mixed severity fire are probably more common than in our stand replacing type. You know, recognizing it's still only one line of evidence from one snapshot in time, what we can see is the patch size of our mixed severity forests in this map are 1 to 2 orders of magnitude smaller than they were in relative to that high severity type. So we're talking about overall generally smaller fires. And so when we think about these forests, granted they're still productive because it's still a Westside forest, but because they tend to experience mixed severity fire, it's possible that some east side principles in terms of managing these stands are actually more applicable in some parts of our mixed severity forest type than say in our stand replacing type. And I'll talk about that a little more. And I'm sure Derek will discuss this more, but more with the perspective of drought. So I'm not going to go into a lot of detail about climate change projections. You guys have already gotten that ad nauseum this morning, even though they were great talks. My spouse gave one of them, so come on, I really mean that. But I thought it'd be helpful and useful to discuss climate change, at least with respect to these 3 factors that I reviewed with you earlier, just to go through a logic exercise. We know climate change projections indicate that our summers are going to be warmer, probably going to be drier, and the duration of that warm and dry period is probably going to increase. And that's nothing to say about the hotter droughts that Glenn mentioned. Well, that all suggests to me that the risk of fire from this one factor is only going to go up. At least personally, I don't feel like the science on lightning and climate change has been really settled. So I'm going to ignore the climate change ignition component of it and just talk about people. All the projections indicate another 2.5 million people will be moving to our state in the next few decades, assuming at least 1 million of those settle on the west side. That means 1 million more ignition sources, also increasing the risk of fire. And so with just these 2 conditions alone increasing, not only can we conclude the overall risk of fire is going to increase, but that would also suggest the overall area burned from fire is also going to increase. How much it's going to increase is debatable. The key question, I think, for us is what's going to happen to these synoptic east winds, the real drivers of landscape change up to now? And the truth is, we don't know. And I think it's partly because no one until recently has thought to even ask the question. So without knowing if these synoptic east winds are going to become more or less frequent or more or less intense, I'm not comfortable telling you what's going to happen to those rare events. Maybe they become more rare in the future and less intense. I just don't know. But it still doesn't negate the overall conclusion that area burned on the west side is still probably going to go up from our smaller to more moderate-sized fires. So what can we do about this? I should start off by saying this is a list several of us have been coming up with over the last year. It is by no means exhaustive, and of course, what you think of some of these options really depends on your management objective, but also whether you're thinking that your lands are in a mixed severity type, or if you're thinking your lands are in this high severity type, or maybe if you're managing for those small to moderate sized fires, or if you're thinking about those large wind-driven fires. And you can see there's some things you could do before a fire that's going to vary depending on management objective, but also where you're situated in the landscape. But a lot of these are common ideas and principles that Dave mentioned earlier and that probably Derek will mention as well later on. So something like a basic stand level fuel treatment, it's not going to be applicable everywhere in our mixed severity type, but it may be in the drier portions of our mixed severity type. It makes sense to implement some of these, maybe, or maybe not from a fuel perspective, but if you're going to be managing for drought, it's going to have some of those same benefits. In contrast, I can't really argue or think of a great reason to conduct a stand level fuel treatment in some of the most productive forests in the world in our West Cascades high severity type, right? How in the world could you conduct those sorts of treatments and then repeat them, every 5 to 10 years? It's just not tenable. It's not practical. Conversely, something like applying fire-wise principles around high-value resources like your homes, that makes sense in our mixed severity fire type, and it makes sense if you're planning for those small, non-wind-driven fires in our high severity type. But just recognize that when those wind-driven fires come along, it may not matter. It didn't matter in California during the Camp Fire. They had all of the fuel breaks you can ever imagine, and those embers the winds blew the embers miles in front of the fire. Now, with that happy thought, there's actually a whole bunch of other options that you can consider doing, and guess what? You can implement them irrespective of where you are in the landscape. It's just, what I've recently realized is most of these aren't actually things you physically implement on the ground. It's just ideas or concepts and things to consider. So other than removing ecosystem stressors for reasons that Dave mentioned earlier, what we're also talking about is coordinating with your adjacent landowners, limiting human ignitions, right, or aggressively detecting wildfire even better than we currently do. And perhaps one of the more important ideas that we can do today is develop our post-fire response strategy. So what are we going to do after a fire occurs? Maybe we'll do exactly what we've always done in the past, which is what we would do if we probably didn't develop any think about this right now. But maybe given climate change, there's some things we'd like to do differently. And at least whether or not we change our management when we think about it by thinking about post-fire response strategies now, we can at least be purposeful when the time comes, right? As opposed to panicking and just always doing what we did in the past in the moment. Now, during a fire, your options are kind of limited, right? You can either suppress the fire or you can let the fire go. Now, there's some really good reasons to suppress fire. Maybe you're managing for a condition on your landscape, whether it's a habitat, whether it's you're going to harvest that stand and you don't want it to burn up. There are lots of different reasons. And so if you're managing for a condition, of course, you're going to aggressively suppress that. But maybe in the mixed severity type, a little bit of fire is good because it's going to diversify your stand. It's going to achieve some of your management objectives for you. So maybe in some instances, you want to let it go. Or maybe part of your management objective is to allow natural processes to occur, like fire, because a basic restoration ecology tenet is a functioning forest will materialize when you have a fully functioning system, including all the processes. So maybe depending on your management objective, you permit fire. That's up to you. It just comes with the recognition that you don't want to do that during these wind-driven events or synoptic east winds. And there's always a greater risk when you do it, even for these in this high severity type without a wind, because a wind could always pick up. So it comes with additional risk. Now, what you do after fire is our ideas that Dave mentioned before, and again, Derek will probably mention some of these afterwards. Obviously, one of the first things I would imagine you'd want to do is assess the impacts of the fire relative to your management objectives, right? Again, it may further some of your objectives. If you're in that mixed severity type, maybe you're really interested in creating complex early seral habitat, and so you're happy with some of those impacts. I don't know, but obviously we want to assess those impacts because they could be both positive and negative. We're probably going to leverage natural regeneration. It's a cheap and inexpensive way of diversifying your landscape. And the reality is, many of us probably won't have enough funds to replant everywhere we want. And if the fires are big enough, there's going to be competition for limited seedling stock afterwards. So even if you could and wanted to replant everywhere, there's probably a good chance you wouldn't be able to. Dave talked a lot about promoting species diversity within and across stands, including hardwoods. And coordination is always a good thing. And of course, I wouldn't be a card-carrying scientist if I didn't advocate using these fire events as learning opportunities. When I say that, though, to all of you, I'm not thinking of setting up true experiments. I mean really basically just doing what you always do, watching and learning from the forests. It's just these Westside fires to date have been so rare for the last several decades, if not longer. There's a lot of basic information we don't know. And so as we can learn from these, it's more like passive learning, right? And we just absorb, but as important it is to learn is to share what you learn with others in the community so we can all benefit from all of our knowledge together. And with that, thank you all again for your time.